This video is about my valiant yet failed attempt to derive a way to compute curvature, which is that thing from Calc 3. So here's my approach. It was basically to construct a general 2D circle in 3D space, and then use a system of equations to fit the parameters using the first and second derivatives. However, there were some problems that I encountered with this approach. And this is why I will mostly focus on the construction of the 2D circle in 3D space. The problems I encountered were basically that I had 5 variables and 6 equations, meaning that the system was overdetermined. So basically, in this video, I learned that coordinate systems are expressed in terms of a point or a center of the coordinate system and a basis set of vectors. So basically, a way to switch from the first coordinate system of the x, y, z to the second coordinate system of the xt, yt, zt is described by this simple equation. So we have the origin p sub t is that second coordinate system xt, yt, zt. Then we have the origin O is the center of the xyz coordinate system. And we have the basis vector set b1, which are just the orthogonal basis vectors that align with the axes. So now we rotate this xt, yt, zt coordinate system such that we enter the xr, yr, zr coordinate system, and it has a center of p sub t and a basis vector set of b2, which are orthogonal vectors that align with the axes shown in the diagram. So in the xr, yr, zr coordinate system, the zr hat unit vector expressed in terms of b1 is the axis expressed in terms of b1 vector over the magnitude of that. The yr, as shown in the diagram, yr hat vector expressed in terms of b1 is equal to pc expressed in terms of the second coordinate system, the xt, yt, zt coordinate system over the magnitude of that, which is equal to pc minus p sub t expressed in terms of the first coordinate system that has a center of O and a basis vector set of b1. And we construct the third one in terms of b1, which is the xr hat vector, by taking the cross product of the pc and a in terms of b1, in that second coordinate system of the xt, yt, zt, and we'll express that here in terms of the first coordinate system as the equation on the right there. So in the xt, yt, zt coordinate system, we have the constraint that p sub c and the axis must be perpendicular. That means that there's a constraint on p sub tz, which is the z component of the location of the center of the circle in the first coordinate system, described by the center of O and basis vector sets of b1. So here's a summary of what we discovered. And now we move on to constructing the circle. Xr squared plus yr squared is equal to capital R squared, which is the radius. That is in terms of the third coordinate system, the xr, yr, zr coordinate system, whose center is p sub t and whose basis vector set is b2. So here is that equation parametrized by t. And now we express that same circle equation in terms of the second coordinate system, whose center is p sub t and whose basis vector set is b1. And then we describe it, the same equation, in terms of the first coordinate system, whose center is O and whose basis vector set is b1. And I do not have a picture over here. Sorry about that. And I did not make a transition matrix, so I'll just kind of cheat and say that r is equal to PC minus PT in the original coordinate system, because I would have needed a transition matrix to go back to the other coordinate system, but I didn't make that. I would have to take the reverse of it, but from the diagram you can see that it's equal to that. Alright, so here is the equation of the circle in the first coordinate system that has center of O and basis vector set to B1. And from this circle equation, we can make a MATLAB program that expresses the circle in blue right there, the center of the circle in dark blue, a point on the circle in green, and the axis in, I think that's orange or dark orange. So I actually did not derive curvature, but at least I tried. I ran into some complications with the equations being overdetermined, the system I mean, but at least I made a cool circle. And on the next slides, I'll show my MATLAB code. Here is the first part of my MATLAB code that I used to make the plot. And here's my function plot circle that I used to make the plots also. And that is the end of this video.